Hey everyone, welcome back to the channel. Today we're looking at just how easy and quick we can set up a GraphQL API in Golang. So Go is typically not a language that I see used very frequently for GraphQL servers, but it's 100% doable and it's actually pretty effective and pretty clean. And this channel kind of specializes and focuses on Go, so I just wanted to show how easy and how doable it is. So today we're going to set up an API and deploy that API onto Heroku. So first off, I'm just on graphql.org. We can go to code here, and right here we'll see all of the different languages supported with GraphQL, and you can see different libraries available for each one of them. So if we go to Go here, you can see server, you can see client and tools as well. So for server, this is what you would be using. You want to use one of these libraries here if you're building on an API, right? So you're serving resources to clients or users. Also in Go, if you want to consume other GraphQL APIs, there's a bunch of libraries supported for doing that. But for us, we're going to build a server today, and you can take a look at these and kind of play around with each of these. But one that I would highly recommend is 99 Designs gqlgen. This is a really handy Go library here, and a big selling point that I really like about it is that you set up your GraphQL schema, basically a single schema, and you give this library your models, so your schema essentially, and then it generates types and it generates resolvers based off of your schema. So you have one schema, and it's actually written in GraphQL syntax. And then based on that schema, we generate out Go files, and then we can use those and implement our resolvers using those automatically generated types. So that's a big selling point for me. If you look here, all this different language support, a big part of GraphQL is you want to have a single schema, just one schema, GraphQL schema, and then you'll have many clients, many servers that will use that schema. So you don't want a GraphQL library like auto-generate from that schema, right? So you have a single schema, single source of truth, and all of your clients or libraries, your front end, if you're building out a front end app in React, would generate queries, mutations, types, everything like that from that schema. Your backend, your server, would generate the types from that single schema, right? So you don't have a duplication. You don't have to duplicate that schema across many different repos. So that's why I really recommend gqlgen here, because you have that single schema, that single source of truth, and then it automatically generates types from it. Some of the other libraries, for example, you have to manually create Go structs, and then it does things for you. So you'd have to manually create a bunch of different structs, and then for your front end, you'd have to go back and manually create all of those types too. You wouldn't get anything generated for free. So yeah, that's kind of why I recommend gqlgen here. And there's comparisons here. If you really want, you can see all the features gqlgen has, and then some of the other common libraries as well. Obviously, this page is put together by gqlgen, so I kind of expected to say gqlgen is the best library in the world, but there's probably some trade-offs. And if you really want to, go ahead and dig into these others and play around with them too. But today we'll be using gqlgen. Another great thing that I like about it is that they have a really excellent quick start guide for setting up a project. It sets up a bunch of source code, a bunch of tooling, everything you need really to get going with the GraphQL API. So we're going to follow their steps here, and then we'll make some modifications and some additions that we'll need to build our API as well. So the first thing we'll do is just set up a directory, and then set up a Go project here. So let's do that right now. Okay, so that's taken care of. Second step. So gqlgen uses some tooling basically to take that schema that we had and generate files from it. So here's this command here that essentially pulls that down and writes some code into a new file, tools.go. So let's go ahead and run that, and then after we'll do go mod tidy that will add dependencies and clean things up. So let's do that now. All right, and let's open up that folder. Cool. So now we're inside that folder that we've ran. We have our Go project here. We have some dependencies here. And inside here, we have our tools. And we use this specific import here, this dependency, to actually run a command that gqlgen gives us, go run a command that gqlgen gives us that generates our resolvers and our types. So that's why we have this file here. So next step, we actually run that command. So basically it's go run gqlgen init. So let's open that terminal back up. Let's run it. So this is going to generate a bunch of files and basically give us a server structure that's pre-built, comes out of the box, and it's pretty workable. Okay, so now if we wanted to, we could just run go run server.go, and that would actually give us a fully working functional GraphQL server. Let's walk through the code that they give us. So they set up here, they give us a default port of 8080. This is useful for applications. For example, when we go to deploy this later onto Heroku, we get the port. So Heroku specifies the specific port that we need to listen on. So this is nice that they give us this pre-built out of the box here, already listens for it. And then what they do is set up a server, default server, and they have all of the resolvers, the GraphQL resolvers that we've generated. And they set up two endpoints. So the first one, just the slash endpoint, is the GraphQL handler. The GraphQL handler is like Swagger UI, for example, or Open API. It's basically a UI where users can test queries and explore schemas and types, right? One of the big selling points of GraphQL is that your code is automatically commented, or your code is your APIs are automatically documented, right? There's documentation generated for them. And with this playground here, that's kind of how you go in and see it. You can play around with all the queries, mutations, and types, and use them like that. The second one is the slash query endpoint. And this is where you'd actually fire off your queries. So if your front end would call this endpoint here. Looks like they're just logging out what they're listening on, and then they just start it up. So you notice they're just doing HTTP listen and serve, and this function takes an HTTP handler. So behind the scenes, all this handler new default server is doing is generating an HTTP handler, right? So HTTP handler just needs this. It's an interface that just needs to have serve HTTP, this function implemented. So that's what they're doing behind the scenes. It's just a handler. If you don't want to use their handler, their built-in handler, you could use Chi, you could use Gorilla Mux, you could use the standard library as well, the HTTP standard library in Go. But I really like this library because they give you this out of the box. So another thing you could do as well that you probably want is authentication or logging, things along those lines. So you can do that just as well. You can add in middleware. So you can wrap serve, for example, or you could wrap playground even. You can wrap both these in any kind of middleware you want. So authentication middleware, logging middleware, tracing middleware, anything you'd like, we could do that. So we'll add one test middleware later on. But for now, let's look at the other files that we got generated. So gqlgen.yaml is configuration for generating our schema with gqlgen. So when we ran that init command, it set up all these files. For the future, instead of running a init, we will run generate. So if we make any changes to our schema, we rerun it with generate. So you'd probably have that as some kind of build step or pipeline step. As you deploy your app, you generate the types. That's one way of doing it. We don't really need to make any changes here. This specifies where things go, so where we generate stuff. They're saying graph generated.go, so it comes out here. This is a bunch of types, handling, running our queries, etc. Don't need to worry about that file too much. Package name, you can change that around. And then where do any models go? So remember when I said you create a single GraphQL schema, this is their schema that they give out of the box. You create the schema, and then types or models are generated from that schema. So we look model, slash model, models gen, and then here's our types, right? So let's split this, and let's open up schema. So here's all the types generated. So here's the GraphQL type, and here's the golang type that was generated automatically for us. Yep, so that's specifying that. And then where do the resolver implementations go? So we have a query and a mutation. So we have a query right here, to-dos, which gets us all of the to-dos, and then we have a mutation, create to-do, which creates a new to-do. And this section here is specifying where that goes. So directory graph and resolver.go is the file that it comes out in. And then there's a bunch of other configuration here. Won't go too in depth into this. This is specifying types. So GraphQL has an ID type and an int type. Go has several int types, and Go has a bunch of different things that you might want to use for IDs, right? So GraphQL out of the box for an ID usually uses like a UUID, a really long string, but you can also have ints. That's kind of just showing some customizations that gqlgen can do. The other type here is int, and it's just saying we can represent that with all these different types. With all these different types within Go, int32, int64, or just regular int, etc. All right, so this is kind of our config, and again, when we make changes, we'll run this command, go run gqlgen generate, and that'll update all of these files for us. Okay, so what do we actually change now with this generated stuff? Well, within the schema.resolvers.go file here, we see all of our generated mutations and queries. So we see create to do, and we see to do's, and there's just a panic statement in here that says, hey, nothing's implemented yet. So we can implement these right now, and we can see that basically we need to return a model to do when we create one, and then for the query we need to return this array of to do's. So let's do that and just get these running for now. So we can return, and let's see, what does it take? And it also returns an error, so we'll just say nil. Oh, and actually we have this input, so we can make this, even though this is just mocking it for now, we can make this look a little bit better. What else does input have? Has the user ID. Okay, and then here we want to return an array of to-dos and yeah, that's fine. We can just have an empty array. So this would run, but one of the other things you see here is we have context. So remember we talked about how we can add in middleware, like a logging middleware, tracing. We can put whatever we want into this context, and then we can pull it out here. So for example, one of the things we might want to do inside of context is have our database, right? So we could pull, if we're creating a to-do, we probably want to write that to a database, right? So you could probably pull get db from context and then pass in ctx, and that would get our database from the context, and then we would do database, you know, write to do, etc., and that would actually store it somewhere. Maybe we're doing some kind of SQL DB or something like that, and that would actually write this into our database. So we'd have persistent storage there. For us, we're just going to do in-memory database, but we'll actually set up this this little hook here to pull our storage from context, and we'll actually save that in there. So to do that, we will add a new folder here. We'll just say store. Within store, we'll just say store.go. And we will have type store struct. And inside of here, we're going to have our to-dos. So this will be an array of model.todo. And we need to put the package in on top. Okay, So this is basically going to be our store. We'll have a list of to-dos, and that's where we'll store our stuff. So let's set up a new store. We'll set up a function to create that. That's going to return just a store pointer. So we need to make our empty list of to-dos, and then let's return a store. Okay, so that sets up the store. Let's also, we'll make a middleware, so a with store middleware. This will inject store into context, and then we'll say get store. What do we call this? Get db. We'll get store from context. We'll do that. Okay, so there's two functions that we're going to do here. So with store is going to be our middleware, and that's just going to be a regular HTTP middleware that injects our store into context, and then we're going to do get store from context, and that's going to pull it out. All right. So for middleware, basically we need to put a HTTP handler. If you don't know how to write middleware in Go, HTTP middleware in Go, I'll put a link in the description that has a good article on it. You can read up that. Basically, we just need to implement the http.handler interface. So let's do that. Say with store and next http.handler. And we need to return a handler too. So let's return http.handler func. And that's going to take a function. And that's a W response writer, then a request. Serve HTTP and request. Now we need some way to give this middleware our store, so it will take it'll take a store. So this will be the store that we've set up. All right, so now we basically need to set up a request with store, and we're going to say r.withContext. So we're going to take the old request and we're going to add onto its context. So with context, context.with value. So it takes the parent context, it takes a key and then a value. So the parent context is r.context, the key will be store, and the value is store. Yep, and then serve HTTP. So instead of serving this old request, we serve this new request that has the store context put into it. Yeah, so that's just a really simple with store middleware. So the next one is going to be get store from context, and that's just going to return a store. And to pull that out, we're going to say store, takes in a context, and we're going to say store equals context dot value and store. And we want to cast that as a pointer. And this returns okay. So you could do if not okay, panic or return. You could add an error that you return up here. I'm just going to panic. Otherwise, we'll return the store. So if you're doing production, probably return an error. Don't panic here. All right. And best practice too for context keys and values, don't use a hard-coded string because other middleware could use that same exact string. So typically you'd see like store key type string and then all right. So typically you would see this is a better pattern here. So you would set up its own type, store key type, This could be anything and whatever, but then you would set up a store key that is that type. So now other context, other middleware would not kind of override this. It's a different type, so it wouldn't interfere. So that's set up. We're using this good practice here with context. So the next step is let's set up that middleware. So we'll create the store first. New store. Yep, declared but not used. The next part is just adding in the middleware. So basically what we need to do is just wrap serve this handler with our stored middleware. So store.with store, and then it's just serve. And I think we need to pass in our store as well. Okay, what's this error? All right, so we're setting our variable here to be store, so we're overriding the package. So I'm just gonna say db, sure, we'll use that. Naming is tough. Okay, so we have our middleware, passes in the db, injects it into the context of all of our requests coming in. All right, so now with our resolvers, we can pull that db out, and we can do fancy stuff with it. So db equals get store from context. Okay, so there's our database, and now we have access to the to-dos. So we could probably write a helper function that actually saves it, and then a helper function that retrieves it. So let's do that. So new store, we've got all of our little context helpers. So up here, I'm going to put s store. So this is like our helper function that updates to-dos state, right? So this would be the equivalent, when you have a DB, this would be the equivalent of your little query. So save, we'll say add to-do. And this will take just a model dot new to-do, that's fine. And this will just return an error. Okay, so s.todos, and we're just going to append it, basically. So this is a new to-do, so we need to make a from there. All right, so this updates our state, kind of abstracts that out, so our resolvers don't have to worry about doing this. So if we go back now, that's fine. Now we can do db.addToDo input and pass the address in. What does that return? That returns an error. And we'll handle that. Otherwise, we'll just return this same object here. Okay, so down here for the resolver now, when we want to retrieve all of our to-dos, now we can get our storage, and instead we can return db.todos. Everything we have stored right here. Let's go ahead and run this now. So you can just run, what was it? Go run server.go. And that should start up our server, and we can open up the playground next and actually play around with all of our code. So yep, we'll allow that. Cool, so we're on localhost. Here we can see, this is the playground here basically. So we can see, remember we talked about how there's pre-built documentation, we kind of explore the different stuff. We can open up query, and we can see we can query for all of our to-dos, mutation, etc. So that's what it looks like. Let's build a query and get our to-dos. To-dos, and let's see, ID. What else do we have on to-do? Text, done, user, ID, name. So if we run that, we don't have any to-dos saved, so it's just that empty array. But now we can make a query, we can make a mutation to do that will create a to do. And what does that take? That takes input, which is going to be an object that's a new to do. So it's going to take text and a user ID. And that's going to return a response. And let's query the whole to do from that response. All right, so let's run create to do. And there we go. We see we've created our to do. Let's run get to dos and see if that store was updated. Yeah, cool. So our little in-memory storage is working. Create another one, get them, and there they are. Yeah, so that's not persistent storage. That'll be erased every time we restart our application. But you get the idea. So that's really how easy and quick it is to set this up. If you want to change your schema around, also pretty straightforward and fast to do. For example, we can add comments here. Maybe we'll have an email, which is just an optional string. Okay, and we want to regenerate things, so let's go ahead and do that. gql. So instead of running init, we're going to run generate this time. And there's a couple things we should see. So there we go. And now let's run our server again. Go run server.go. Allow. And we're set up here. But now, so you can see here, we updated the documentation for user. At the start of the video, we talked about how GraphQL is kind of self-documenting. So all those comments that we put in our schema will actually show up here in our playground, so that users of our APIs can see that. Here we see email string. So what happens, for example, if we got rid of a mutation? So let's say we rename this to add to do instead. So it's not create to do, it's add to do. We'll see what we need to do then. So now if we go to schemas .resolvers, we see the new one is created. We changed it from create to add, and it's got just the default panic not implemented. Our old query is still fine. This is gonna update and resolve. But down here, you see this new part. Was gonna be deleted, code is gonna be deleted. So basically any old code that isn't used within the schema is gonna get put down here. So you can either just erase this entirely, or you can keep this and kind of comment it out, work with it, do whatever you want. But yeah, so when you add new queries and mutations, you'll get new resolvers that you need to implement here, and you'll get some old code to clean up down here. Okay, so that's looking good. Let's undo that. Let's undo this. We'll rerun generate just to clean things up. Okay, but there's our server. There's our GraphQL API. So now let's finish this out and let's get this deployed. All right, so before we deploy, I want to talk a little bit about what we're going to do next, and that is containerize or Dockerize our Go application. So I'm a really big supporter, really big fan of using Docker whenever you're working with Go. Go, one of the parts that we do once you finish writing your code, it all compiles and gets generated into an executable. Now that depends, executables kind of depend on whatever architecture or operating system you're using. So for example, you're on a team of 3 developers. One developer uses a Windows machine. Why? No idea. They just like Windows. Another developer uses Linux, and another developer uses Mac OS, right? So we can all be working on the same DevTopics GQL API or server, but all 3 of us are going to generate and use a different executable, a different binary, right? So when you run go build, you can also specify the output, the architecture. So you could use Linux, you could use OS X, you could generate a binary for Windows, etc. So 3 different binaries, right? That can make it a little bit interesting, a little bit difficult to work with. So instead of that, we use Docker, so that it doesn't matter what OS you're running on, as long as the OS can run Docker, it can build and run our application. So one single command, one go build, generate an executable for whatever Docker image we're using, whatever OS that Docker image is using, and it's good to go. Similarly, by using Docker, we open ourselves up to to a wider range of cloud providers. So maybe, for example, if today we're going to do Heroku, maybe we would customize, if we weren't using Docker, we would have to customize some things to get this deployed onto Heroku. If we were running this in an EC2 instance on AWS and we were not using Docker, again, there'd be some things we have to customize, right? So maybe the EC2 is limited to the operating systems it can run. Maybe it only has Linux. Maybe it only has ARM processors available to it, etc. So without Docker, we're kind of limiting ourselves to generating an executable that runs only on that EC2. And if we ever want to move over to GCP or Microsoft Azure, other cloud providers, there's going to be a lot of work translating and transforming our build scripts, our code, just to get it to run on those other providers. So using Docker, number one, it makes it easier to develop with multiple team members who maybe use different operating systems, but also it opens up a wider range of products that we can move across to, right? So we can easily deploy a Docker image onto Heroku, easily deploy one onto GCP, AWS, Azure. Many, I'm guessing the majority of cloud providers out there will offer some support for Docker. Yeah, so that's kind of, highly recommend using Docker. Get familiar with it. It's pretty straightforward to do. But that being said, let's go ahead and set up a very simple Docker file, and then also Docker compose.yaml so that we can do local development and boot this up and run it. So to get started Dockerizing our GraphQL API, we're back in VS Code. I'm just going to make a new file. We're going to call this Docker file. We'll make one more file, and we'll call this Docker compose.yaml. All right, so Dockerfile, I kind of use this similar pattern in many of my other videos. So if you've watched my other videos that also use Docker, you probably know what we're doing here. But we pull from golang as our base image. This basically lets us run, build Go inside these Docker containers. Next, we're going to set up a kind of directory to work from in here that isn't just the default directory. We're going to add all of our source code into that directory that we just made. So everything in here that would contain all of these files here, our server, tools, graph, etc. And then we're going to set our working directory, so the current directory basically, to be app. So now any commands we run will be run inside of app. And we're just going to build our executable, our binary here. So that's saying go build a binary, output what we name our executable. It's going to be main, and then it's saying build from the current directory. Next, we're just going to expose our port 8080, and our command that we're going to run is just run the binary the executable we just made. So app/main, and that's it. It's pretty straightforward. So one thing to point out here, if you want to improve this Docker file, make this a little bit better, we're pulling in all the source code. So every bit of source code we have is going to be in every single Docker image that we build. You don't have to do that. A better way to do this would be kind of use stages. Let me pull this in here. So multi-stage builds, basically. So it helps out keeping the image size down. So when you have builds like this that need the source code and it just runs a single command, but after we generate our executable, we don't need any of the other files in here, right? We don't need the source code. We literally have just a single binary. That's what we care about. That's what we want to upload. So maybe we have, you're working on a big API, you're going to have hundreds of files, tons of resolvers, lots of code going on, but we don't need that to clutter up our Docker image. So you can kind of shrink your Docker image by using stages. You could have, your first stage. First stage is, pulling secrets, environment variables. Second stage maybe is actually generating the binary. And then third stage just ships the binary. Right, so this stage would have all your code and this would be the biggest image, but that's not the that's not the image we would be uploading and using. We could just ship a very minimal image here that just ships the binary. So I'm not going to implement that. I'm not going to really go into depth on how to do that. I'll leave that up to you. If you want to productionize it, I would recommend using stages and pulling these out into different stages here. Okay, so there's our Docker file. Let's move on here. So Docker Compose. We're going to have a service. We'll just call it web. And to set that up, we'll just say build and the current directory. Ports, we're going to specify, we just have 8080. That's our API, and we'll expose it to 8080. And then the environment, and we actually don't have any environment variables we're using here other than port. Let's see, let me double check that. So we look for port here and it's 8080. Okay, so we can set that. Let's set, I don't typically use that syntax. Let's do port 8080. Okay, so now our server code can actually pick up that port. Okay, and when we deploy to Heroku, Heroku sets this dynamically for us. This won't always be 8080. Okay, so let's just make sure this is working. And we'll do Docker Compose down and Docker Compose up builds. This should just run it. All right. Okay, tools. Okay, so found main and tools in /app. Package tools, package main. Okay, so simplest way to fix that would be we'll set up tools here and we'll move our file in there. And again, the reason we have this here, this gqlgen dependency isn't really used anywhere else. It's not used in our code, but remember it is used to generate our models. Basically, it's used to generate all of the types and the resolvers and the models. So having this here ensures that it stays in the dependency, right? Otherwise, we couldn't keep it in. We couldn't put it into our Go modules. So that's sort of the purpose of the tools. Whenever you see tools within Go, that's typically the purpose. It's some script or dependency that you need, but isn't really used in the code. So typically stuff you would run on your CLI. All right, so let's see, hopefully that fixed it. Yeah, cool. Okay, so we're up running on 8080, and let's just pull that open. And here we have our queries, get to do's. Let's create one and let's get it. Yeah, so things are working. Our Dockerized API is all up and running now. So we can move on to deploying this onto Heroku now. Okay, so I've signed into my Heroku and I'm just on my dashboard. So let's create a new application here, a new app, and we're gonna call this dev topics gql API, and we'll create our app. All right, so this is all set up here. If we were deploying this by Git, we could use this, and we could use kind of this guide right here. And every time we pushed up, it would trigger a build. We're doing Docker, so container registry over here. So we can kind of follow this, this guide right here. So the first thing you'll do, if you haven't already, will first install the CLI. I've already done that. I'm not going to run through that, but just follow the guide. The second part, you're going to log in. So Heroku login signs you into Heroku, lets you use the CLI. And next, so they're saying you have to have Docker installed locally. So I'm assuming you have that done. And then you sign into the container registry. And basically there's two commands you'll run. So the first one is push. That actually pushes your image up. So you can have a bunch of different images. You can roll back to older images, etc. You know, in case you release something and it's broken, you can just roll back previous deployed images. And then finally you can release, so Heroku container release, and that will release your latest image. So let's go ahead and run those commands. Docker compose down, let's close those out. We don't need these anymore. So I'm going to run Heroku login and I'll sign in. So we can close that. Let's jump back. And we need to do container login. All right, and now we can do Heroku container push web, and usually I just combine both these, so there's an and. I'll do them one at a time. Okay, we need an app here, so let's specify our app, and what do we call it? Dev topics gql API. All right, container's pushed, so we can release this now. So Heroku container release web, and we need to specify our app. Heroku container release web app. What was it? Dev topics. And if you don't want to have to specify app every single time, like we're doing, this will go away if you set up the get remote, so the get remote. So while that's going, okay, couldn't find app. Okay, so 1 second. Yeah, so if you don't want to specify the app, what you can do here is just set this up, and this Heroku will automatically pick this up. So if I do this, for example, then I can do web, and it should pick up the app automatically here for us. All right, cool. So we pushed our container, and now we have released it. So we should be good to go, and we should be able to go to the endpoint and actually see our playground now, but from Heroku. We can run Heroku open here, and that should pull up our app. Yeah, okay, so we see we're in our GraphQL playground. I think I can just copy over these from our localhost one. So we can check out the docs, we can see our queries to do, and we can see our mutation here, and all of that. Here's that description, that comment that we put in, and it's the user type here. But yeah, we can run our queries here. So get to dos. You see we have no to dos, and let's create a couple. There's the first one. Let's create another, and then get them. So we see we have 2 to-dos now. Okay, awesome. So that is how we deploy here. We're on to Heroku now, and hopefully, because we used Docker and Docker Compose, you can pretty much take this base server anywhere you need to in the future. Yeah, so hopefully that was helpful for you all here. We went through and set up a GraphQL API with gqlgen, and we also showed how to set up middleware, so you could do things like database injection or authentication. If you watch my series on authenticating with Amazon Cognito, with AWS Cognito, you could set up middleware that would verify tokens on every request. So if you haven't checked that out, go back and look at how to authenticate your applications using AWS Cognito. But beyond that, thank you all for watching, and I hope you found this video helpful. Please make sure to like, comment, and subscribe to the channel. Helps the channel grow, and it helps me keep making these videos, lets me know I'm doing something right that you find helpful. So if you found this video at all helpful, please make sure to like, comment, and subscribe to the channel. Thanks for watching, and I will see you all next time.